Alright, hello everyone. I hope that you're all doing well. So we are ready to look at Module 4 on linear functions. So we're going to start by talking about lines and the slope-intercept form of a line. So the slope-intercept form of a line is y equals mx plus b. And we call it the slope-intercept form because it very easily gives us our m, which is slope, and our b, which is the y-intercept. Okay? And we learned about average rate of change last week, and that's very much the same as the slope. So we're going to find the equation of a line in slope-intercept form that goes through the points -9, 3, and -6 and 1. Then classify the line as increasing, decreasing, horizontal, or vertical. Well, we first have to find the slope with our slope formula that we had from last week. y2 minus y1 over x2 minus x1. And then, of course, we need to label these x1 and y1, x2 and y2 so we know what we're doing. Okay, so we're going to replace y2 with a 1. We're going to replace y1 with a minus and 3. We're going to replace x2 with -6, and x1 is -9. Now notice we've got two negatives, so we're going to have to add those. 1 minus 3 is -2. -6 plus 9 now is +3, so we're left with -2/3 for my slope. So I'm just going to write m is equal to -2/3. Okay. So if I'm to write my equation, I'd have y is equal to -2/3 x plus b. I don't know b yet. Okay, so that takes us to part 2. Part 2 is going to be finding b. This is accomplished by plugging in one of the points into your equation. It does not matter which one you use. I think we'll just use this -9/3 as our example point. Okay, so I'm going to rewrite this as 3 is equal to -2/3 times -9/1, because I want that to look like a fraction, plus b. So all I did was I replaced the y with the 3, which is the coordinate here, and I replaced the x with the 9, which was part of my coordinate. Okay, now I'm going to scoot over and I'm going to multiply. 2 times 9 is 18, but those are both negatives, so that becomes +18. 3 times 1 is 3 plus b. 3 will go into 18 6 times, because 6 times 3 is 18. Now I need to subtract my 6 on both sides, because I want to solve for b, so I'm left with -3 equals b. Okay, so finally, my equation is y equals -2/3 x minus 3. Okay, so finally, after those 3 steps, I found my equation. Now, this is a negative in front of my slope. When it's a negative in front of my slope, I know that I'm decreasing. Okay. And yes, it is a function because it's going up 2 and over 3, up 2 and over 3. So it's making a slanted line. Okay, so it is a function. Okay. Then if we scroll down to example 2, find the equation of the vertical line that contains the point -2 and 9. That's important. It says vertical line. Vertical lines are like this. Okay, vertical lines do not have a slope. Or, in other words, we say that it's undefined slope. Because you're going up, but you're not going over any. Okay, you're just going up and not over any. So the slope can't really be defined because by definition that slope is that rise over that run. This just has rise, it doesn't have any run. So the slope is undefined. And it wouldn't be a function because of that fact, okay? It's not a function because of that fact. Now, and you also think about this as you're going over 0, right? You're going up but over 0. And we know we can't divide by 0 because that messes up a function. So it's also why this isn't good. Now we can write the equation. The equation for a vertical line is always just the x coordinate of your point, okay? So this is the x equals 2 line, okay? Because a vertical line, it doesn't have anything else. It doesn't have a y. It's just that x, and it's cutting through some x on our coordinate plane, okay? Now find the equation of the horizontal line that contains the point -2 and 9. What is the slope of this line? Is this line a function? So horizontal lines, they run but they don't rise. Okay, so we got some run but we don't have a rise. And that's okay. We can have a run without a rise, okay? Because in this case, there's rise over run. So your 0 is on top and your run's on the bottom. And we know that we can divide any number into 0 and just get 0. It's just that we can't divide by 0. So this is a function for that reason. Now I just told you all the slope is just 0 because we're not going up, we're just kind of scooting right on along where we are. So it is a function with a slope of 0. So horizontal lines have a slope of 0 more generally. So anytime you run into a horizontal line, the slope's 0. Anytime you run into a vertical line, there's no slope. Okay, those are your general things to remember. Now, a horizontal line, its function is through whatever the y is. Okay, in this case, the y is 9, so the function has gone through the 9. Okay, whereas with the vertical, it was going through the x value. Okay. So in seawater, the pressure P is related to the depth D according to the model, where D is the depth in feet and P is in pounds per square inch. In this function linear? If so, identify the slope and y-intercept. Okay, so we can look at this and see what we have. So we have two different pieces, right? And they've just got that common denominator. So if I wanted to, I could really manipulate this to where it's looking more like that y equals mx plus b. Because right now you might look at that and you might say, I don't see it. Okay, but if we rewrite it like this, you can see it better if I put the d out in front instead of right beside of that 18. You can see that this looks a lot like y equals mx plus b. And we're able to accomplish this because it has the same denominator or bottom to my fraction. So I can just cut it up in two fractions. So then this would be my y-intercept, not that this problem asked me to find that. And then this would be my slope. Okay, so I'd go over here and I'd say, yes, it is a linear function because it can be wrote in the form of y equals mx plus b. We don't have to write all that down. Okay, that's just y, in case you were curious. And the slope is 18 over 33. Okay, 18 over 33. And you know we call slope m, so maybe we need to put that there. I don't know. Sometimes I go on a trip and I assume that we know that. Okay, and then 496 out of 33 was that y-intercept. So yes, it's a linear function. Okay, so just a little bit of manipulation and we've got that. Okay. Find the following lines in slope-intercept form. So we're trying to find a perpendicular line. Perpendicular lines have opposite reciprocal slopes. Okay, those are big words right now, so I'm going to define it. Let me make sure I'm spelling reciprocal right, because that's the... Listen, I have to look that up every time. You'd think I would know as many times as I write it down. Okay, so opposite reciprocal. That means if it's positive, it becomes negative. If it's negative, it becomes positive. Reciprocal means to flip. Okay, so what was up here goes down here. Okay, so in my little flippy illustration here, it would now be y on top and x on the bottom. Okay, so reciprocal means you flip it. Okay, so just move them up, or down. So let's firstly, we need this in y equals mx plus b format. Okay, it's not working for me in the format that it's in. So I'm going to take, my notes took up a good bit of my space, so I hope I've got enough room. That's why I wrote them smaller. Okay, so I want this solved for y, and that just add to x. Okay, so that means I got y is equal to 2x's plus 1 more x. That's 3 x's. Okay. This is the original. This is my original. But I want to make the perpendicular. And it has to go through this point. So really I'm going to be forgetting about this y-intercept because I need a new one. You need a new y-intercept whenever you want it to go through a specific point, because it's the y-intercept that tells you, excuse me, that you have cut through that specific point. My apologies, it's beginning to be the pollen season, I think. Okay, so we're going to move this into what we've done. Well, it was positive, so that means this is like what, part 1, but it's really like the prequel. Okay, and this is part 2. So it was positive. What if it was positive? It becomes negative, so I'm going to rewrite a negative sign. And then I said I flip it. So this is really 3 over 1, because we can rewrite any whole number with 1 under it. So I'm going to flip it. So the 1's going to go in the ceiling, and the 3's going to go in the floor. And plus b, because that's what I'm trying to find, is that y-intercept. So now I've got, don't forget your x, now I've got that perpendicular slope. So I'm good. Okay, I've kind of went through that part. Now I've just got to find out what the y-intercept is so that it goes through that specific point. And of course we've got our x and our y. So I'm going to rewrite it maybe up here, because y'all know my writing gets large sometimes and we'll be out of room. 7 is equal to negative 1/3 times negative 4 out of 1 plus b. This one's not going to clear up as nicely as our other one did. Okay, but we've got this. Negative 1 times negative 4 is positive 4. 3 times 1 is 3 plus b. Okay, we need to subtract that, so this is going to be an adventure. Okay, but we've got this. So we're going to have 7 over 1 minus 4/3 is equal to b. Okay, so all I've done to date is I found my reciprocal slope, because the perpendicular slope is opposite reciprocal. Then I've started to plug in this x and y point, so I've put the 7 in for y and the negative 4 in for x. I said that 1/3 is a fraction, so let me turn my whole number 4 also into a fraction. And then I've multiplied my fractions across. And then I've said I'm trying to isolate for b, because b is that y-intercept that I need to know. And I've put 7 into fraction form because it's subtraction, and we got to have it in fraction form. And we've also got to have a common denominator when we're dealing with fractions, so we got to get a common denom. Okay, so that's going to be accomplished by, well, what is it? We got 1 and 3, so it's easiest to just say we're going to turn this 1 to a 3, and we're going to, y'all would probably want me to do that in another step, I think. Okay, maybe y'all would like it right there, I don't know. But don't want y'all to say, Mr. Church, I don't understand what happened there. Okay, so let's just write it in another step. 3 times 7 is 21. 3 times 1 is 3. Now I can work through this. Okay, so I can say 21 minus 4 is 17 over 3 is equal to b. So it's not pretty, and sometimes it's not going to be pretty whole numbers. Now all you have to do is substitute that in for b, and you've done it. Okay, you've accomplished what it asked. It just took maybe 3 steps if you want to think about finding that common denominator as another segment of what you've done. Okay, but really we just had to kind of work it through and manipulate some. So some prior algebra kind of comes in when we have to manipulate, we have to get those common denominators, and we have to remember those things. So I always like to try to explain it in the example what we're doing, because I don't expect us all to remember that all at one time. Okay, and that's all of your work over there. Maybe I should have did it in a different color. We might try that on this one to help you. Okay, so then if we're looking at a parallel line, so I'm looking to have a parallel line. So parallel lines are kind of easier. There's less steps. A parallel line has the same slope, so nothing, no flippy floppy and sign changes on this. So I just need to step 1 is I need to get this into y equals mx plus b format. Okay, so let's rewrite this. 6y minus 30x is equal to negative 18. And I'm just going to carry this over. That's an x. It just didn't want its head. Okay, so now I've got 6y is equal to 30x minus 18. And rewrite that over there, because that's good mathematical form. Okay. I know that in the format the x part's going to be in front, so I just rewrote it in front. You can rewrite it at the back to start with and then move it to the front if you want. Now we're going to divide by 6. Now remember that 6 goes into both. Okay, not just one of them. So I asked myself, well, how many times 6 go into 30? It'll go in there 5 times. How many times 6 go into 18? It'll go in there 3 times. So this is your original line. In that slope-intercept format. Okay. So step 2, we still want y equals mx plus b. Okay, and we've got it. Y equals 5x plus b. Because we're trying to make sure it goes through this point. So we need to find out what y-intercept goes through this point, is what we're trying to do. Because if we did this, then it wouldn't be going through this point, because it goes through whatever point this line went through. Okay, so x and y. So I'm going to have negative 1 is equal to 5 times 2 plus b. Negative 1 is equal to 10 plus b. I'm going to isolate b, so I'm going to subtract 10 on both sides. Negative 11 is equal to b. Okay, so we'll just call this step 3 if we want to. And that's to bring it together. Bring together. So I'm going to bring it together, and I'm going to have y is equal to 5x, because that's my slope. Parallel lines have the same slope, so carry over the original slope. Minus 11, because that's my new y-intercept. It goes through the point 2 and negative 1. Okay. Now this one kind of has less work. It just kind of has some setup notes that we need to write. So this is a vertical line that goes through negative 1. Okay, so x equals negative 1 is a vertical line. Okay, I'm just going to make that note to myself. So the perpendicular line would have to be horizontal, right? because we want this new line to cut it like this. Okay, this is our new, and this isn't drawn to scale. Okay, and this is our old. Okay, so we need the horizontal line that goes through this. Goes through -3 and -5. Well, what did we say that horizontal lines, they take on the y value? So what's the y value in this? -5. So what's that horizontal line? Y equals -5. And that's all we have to do. Okay, so much less work. We just kind of had to make some notes to ourselves, and those are kind of what you'll remind yourself of in your mind as you work through that question. Alright, so moving right along to example number 8. If I can get my scrolling wheel to scroll. So we're still on those linear functions in the same format. Notice we rewrote this as f of x. Okay, remember that's just the same thing as y. So during a summer rock concert, the power went out inside the concert hall for 20 minutes. The temperature in degrees Fahrenheit in minutes after the power outage is modeled by this function. So when the power went out, I guess it was 76.8 degrees in the concert. Okay, I wouldn't have been too excited to have been in a concert that was that warm in the middle of summer. Okay, so the input is M, and what does M stand for? The minutes since the power went out. Okay, the output is T of M. Okay, and that's the temperature. So this is just a setup of us analyzing, okay, what's going on. The slope is 0.43 degrees Fahrenheit per minute, okay, because that's in front of the M. I almost said the X, you know, we're so used to it being X, but it's an M today for minutes. Okay, they can really be any letter. You just have to remember that it's the same format. Okay, and then 76.8, as I said, that was your y-intercept, or the temperature when the power went out. Okay. So determine the temperature when the power went out. So that's the y-intercept. So that's 76.8 degrees Fahrenheit. If you want to, you can also think about this as 0 minutes after the power went out and actually solve your equation. And you know that that collapses to 0. So it's 76.8 when the power went out. Okay. So either way is a solid way to think about that, whether you want to think about it as being the y-intercept or you want to think I solved it. Okay, either one is going to work. So the temperature 20 minutes, so that would be T of 20 is equal to 0.43 times 20. And I forgot to bring up the calculator, so if y'all will just take my word for what it multiplies to, that will work out for me, because I should have brought up the calculator. I've got my physical one set right here, so we'll just do that. 0.43 times 20. So that's 8.6 plus 76.8. So the temperature 20 minutes after is whatever this adds together to get. That adds together to get me 85.4 degrees Fahrenheit. Okay. Now create a graph to represent the given equation during the 20-minute power outage. So this is kind of going to be a little complex because I've got numbers on this axis and these numbers are not right. So let's just say that this is the starting point of 76.8 degrees. Okay. And then we know that at 20 minutes, and I've got my 20 right here. So that actually works out. At 20 minutes, it's at 85.4. So 76, 77, 78, 79, 80, 81, 82, 83, 84, 85. Point 0.4, so like right about here. Okay, it's not an exact science whenever we have fractional pieces. Okay, and then there we go. Okay, it's not going to be an exact science on that. Okay, and that was 85.4. Okay, so High Tech Improvements buys a new truck that costs $42,750. The company depreciates the value of their trucks for tax purposes by $5,250 per year. Company policies dictate that older trucks must be sold once their value declines to $6,000. Write a linear function that represents the value of the new truck based on its age. So this is going to be the y-intercept because this is how much the car was worth when we start. That 5,250 depreciation is going to be your M, or your slope, because that's what you're going down by, and the slope is what you'd be going down by. So the value of the truck is going to be equal to negative 5,250, because it said the value goes down or depreciates, plus whatever amount the car started with. Now we want to find out how many years they'll keep the truck. Well, we know that they have to get rid of it once the value goes below 6,000. So we can plug that in for V of X, or the value of the truck, and solve. Okay, so the first thing I've got to do is I've got to subtract, because I'm trying to get X. X is the number of years. And again, when I subtract that, I get 36,750. Negative 2,550. Again, I'm trying to get to X, so what do I have to do next? I have to divide 5,250 from that. And this should be negative because it was larger. Okay, and then I'm going to get X is equal to 7. So 7 years is how long they'll get to keep the car. Okay, so we're going to create a graph. And again, the graph's going to look kind of crazy because of my axis is here. So $42,750 is right here. And then let's just say 6,000 is right here at 6. It's probably technically not, but we're going to go with it today. And that's at the 7-year mark. Okay. The table of values gives the profit P of N of mowing lawns as linear functions of the number of lawns mowed in for a small business. Draw a graph of the data. Okay, so we know that this is X and this is Y. So when there's 0 lawns mowed, they've lost $150. When they've mowed 10 lawns, they're at negative 90, and this is just kind of not exact. And then at 20 lawns, they're at negative 30. At 30 lawns, they're at 30. And at 50 lawns, they're at 150, we'll say. Okay, we're going to say that that looks close enough. Okay. So find a practical domain and range for this function. Okay, well the domain, can we mow a negative number of lawns? No. So 0 has to be where that starts. And in theory, I guess they could mow an infinite number of lawns within a day. It really probably depends on how long each lawn takes based on its size. What's the range? Well, the range is that when they've mowed 0 lawns, they've lost $150. That's probably because they've had to bring in all the crew and pay them for coming to work and all of that type of stuff. Okay, and then, well, ultimately they could make an infinite amount of money. Their only constraint is how quick they can do the lawns and the hours in the day. Okay, so find the slope and the y-intercept. Okay, well the slope can be found by using 2 points, and it doesn't matter which 2 that we use. I would think that we'd probably just use the first 2 in the table. Okay, now it's important to note that even if you use this one and this one, you're going to get the same slope as us using this one and this one, and that's because this is a linear function. So we're going to have y2, which is negative 90, minus a negative 150. Remember, that tells me to add. And then I'm going to have 10 minus 0. So at least the bottom clears up nice. Oh, that's just 10. And then this is what? 60. So 6. So m, the slope is 6. The y-intercept is down here. So that would be negative 150. Because remember, the y-intercept goes with 0 on the x. So it would be negative 150, comma, 0. I wrote that backwards. 0, negative 150. Because it's 0 on the x, negative 150 on the y. And then we have to write the equation. Well, now we know the equation will be y equals mx plus b. Okay. We might want to use p for profit based on n, the number of lawns. So we could note that p is profit and n is the number of lawns. So p of n is equal to, what's the slope? 6. And what's the y-intercept? 150. So if I were to interpret these, what would I say? I'd say that the slope means that profit increases on average $6 per lawn. Let me just fix that dollar sign, because that dollar sign don't look nothing like a dollar sign. $6 per lawn mowed. And the y-intercept, as we had discussed, means that if 0 lawns are mowed, the profit is negative 150, or a loss of $150. Okay. What would be the profit if 100 lawns were mowed? P of 100 equals 6 times 100 minus 150. 6 times 100 is 600 minus 150. So P of 100 equals 450. So they'd make a profit of 450. Now this is break even is when they've made $0 in profit. So we set the profit to 0, and we're going to solve for n, the number of loans, mode. So first we need to add that 150. So 150 is going to equal 6n. You're going to divide by 6. N is going to equal 25. So they need to mow at least 25 lawns a day to not have a deficit. Okay. The cost of Elena's monthly cell phone bill before tax is a linear function of the amount of data she uses. So she's not got an unlimited data plan. Elena's cell phone bill is $61.60 when she uses 3 gigabytes of data and $97.60 when she uses 8 gigabytes of data. Elena's cell phone plan has a limit of 16 gigabytes per month with unlimited talk and text. Okay. Represent the cost of Elena's cell phone bill in dollars and let X represent the amount of data she uses in gigabytes. Well, first I need to find that slope, and we've got the point that when she uses 3 gigabytes she pays $61.60, and that when she uses 8 gigabytes she pays $97.60. So I'm going to find my slope based on that. So y2 is 97, and I wrote it backwards, is 97.60. And for 3 gigs, or y1 is 61.60, and then we got 8 minus 3. That simplifies to 36 out of 5, which is approximately 7.2. So our M is approximately 7.2. So then we have to go over here and find out the base cost of the plan, which is the y-intercept, and we'll do that like we did earlier by plugging in those x's and those y's. So we're going to have 6160 is equal to 7.2 times 3 plus b. So we have 6160 is equal to 2160 when we multiply that on the calculator. We're going to subtract 2160 to get to b. We're going to have 40 is equal to b. So then I can bring the whole equation together, 7.2x plus 40. Okay, so the first thing we did was to find the slope. Step 2 was y-intercept. And then we end up with our final answer. What is the average rate of change in Elena's cell phone bill? Well, that's the slope. So it's $7.20 per gigabyte of data. We could probably just simply write this as GB, and that would work better. Okay. So what is cell phone bill if she uses no data? That's the y-intercept. And we said that that was what? $40. Now what was her bill if she uses all 16 gigs? Well, we have to plug that in. The C of 16 is equal to 7.2 times 16. And that C comes because we could have wrote this equation as C of x is equal to 7.2x plus 40. Okay, because it's really cost So we should be writing it as a function instead of y. But you're going to get the same answer in the end. Right, and then 7.2 times 16 is 115, 20 plus 40. So that's 155, 20. Okay. And I'm going to leave the graph to you all because I don't want this to be too awful long. And it's already going to be. Now we can look at the domain. The domain is based on the number of gigs of data that she uses. Well, she can use no data, but at most it said she can use what? 16 gigs. So her data has to be somewhere between 0 gigs and 16 gigs. Well, then what's her range? Well, we figured out that the y-intercept is $40 when she uses no gigabytes of data, and that when she uses all 16 gigabytes of data, she owes $155.20. So that means that cost has to be between 40 and 155.20, because the range really tells us the cost of her phone bill, and the domain tells us the gigabytes she's used. Okay, so this one is very similar to what we did, so I'm going to leave that for you all, and we're going to look at systems of equations. So given f of x and g of x, solve f of x is equal to g of x. So I'm going to set that up. So I'm going to have 5x minus 2/3 is equal to negative 3/2 x minus 1/6. Okay. And I want to try to get rid of these fractions. And I think I can accomplish that by multiplying by 6 on each side. Let's see what happens. 6 times 5 is 30. 6 times negative 2 is negative 12 over 3. 6 times negative 3 is negative 18 over 2. 6 times negative 1 is negative 6. Well, I already put the minus there, so I was telling y'all, and then I said, let me write it again. That would be a mistake. Over 6. Remember, that's only multiplied on the numerator. Well, this should collapse nicely. That's just going to be 30x. 12 divided by 3 is just 4. 18 divided by 2 is 9. And 6 divided by 6 is 1. Okay. So that's nice. So multiplying by that largest denominator there worked out really good for me. And I did it so that I no longer had fractions. Okay, that's the whole purpose of multiplying that. So these can combine. Those will just make negative 10. And I can add that 4 over. So what's that make? Negative 6. I lost something. I lost my x. Sorry about that, I lost my x, so that's negative 9x minus 1. So they cannot combine like I was trying to do. You add the 9. 39x minus 4 is equal to negative 1. Then we add the 4. That's 3 is equal to 39x. Okay, that's what I did. I didn't carry down that x is what I had made that mistake on. Okay, at least I caught it instead of sending y'all the video with it still stuck in there. And then you'd simplify. Both of these are divisible by 3. So you get 1 out of 13. Okay. The total cost in dollars of renting a car for a day and driving it X miles from 2 different rental companies is given. Each company describe the rental agreement in words and graph the cost. Use one set of axes for both functions. Okay. So we got these 2 rental companies that we're looking at here. So Company A has a base fee of $30 because that's the y-intercept. And it looks like they call, well, let's turn this to money. 1/5 is what? 20 cents, because 4 quarters make $1. And they charge 20 cents per mile. Company B has a base fee for the privilege of renting their car of $50, and it looks like they're going to charge us 10 cents per mile. So let's say that this is $30, the 3 is 30, and my 5 is 50. Okay, that keeps it pretty okay, I'd say. And then what? This would be, so these are always hard to graph in my mind. So let's use 1 as really, because I've got this counting as dollars. I guess I want this to be worth dollars too, so I guess this would be $10 and $20 and so on. So $10 on this would take me, so 30, so we got 30 plus 20 cents per mile. Okay, so if we did 20, 20, 20, so that would be, let's just do it this way. So I said each of these were $10. $10 divided by 0.20 is 50. So that means we would have traveled 50 miles for $10. So I'd be all the way down here at 50 miles for having traveled, for having spent $10 more. So we'd be at 50 miles and we would have spent $40. Okay, so then at 100 miles we would be at $50. And then for at 150 miles we'd be at $60. And then at 200 miles we'd be at $70. So all I did was I took 10 and divided it by 0.20 to figure out how many miles it took me to use up $10, because I'm counting by tens on this. Okay, so this is miles, because you're counting by tens here in your dollars. So how many miles does it take to use up $10 so that I can move up to the $40, the $50, the $60, and the $70, and so on. And I figured out that for this, it's 50 miles per $10 for Company A. So that's how we worked through that. Okay, and I think that's kind of the easier way to do that, because I was going through circles trying to think of another way to explain it. So then you're going to do the same thing for this. You do 10 divided by 10 cents, and for this company you're getting 100 miles for every $10. So they're going to be at $60 after 100 miles, and they're going to be at $70 after 200 miles. And then after 250 miles, they'll be at $80. Okay, but they wouldn't cross here again on this other line. That's poor drawing. It's poor drawing on my part. Okay, so let's fill in this line as best as I can here, because that'd be $80 at 250 miles. Okay, now if I go back to my other pen, these graphs are always a mess to draw. So at 250 miles, for this person, they're at $70 at 200. And then, that's what I've done wrong. I was counting by the same thing over there. Okay, so it really is what it should be. So you see that they cross right here at the same place. So at 200 miles is where they cross. So it costs $70 to travel 200 miles for both companies. That's what that crossing point tells us. And that's the best I can do with the axes I've got. Okay. Now you can also set these equal and solve. So you could have A of X is equal to B of X, and you can write the function. So 0.20 cents per mile plus the $30 fee, and then 0.10 cents per mile plus the $50 fee. And then you can solve for X by getting the X's over. So then that leaves you with 0.10x plus 30 equals to 50. You can subtract the 30. 0.10x is equal to 20. And then I'm out of room. So 0.10x is equal to 20. Divide that. And you get that it's at 200 miles, which we had. And then we back substitute this to find the cost. Okay. But we don't have to because we're on the graph. At the end of the day, it's probably easier to do it this way. That's the way I would typically do it than try to graph it, because you've got those mental gymnastics going on while you're trying to graph it. So it's cheaper to choose company A up until 200 miles, because you can see it's up underneath company B. So between 0 and 200 miles, it's cheaper to choose company A, because they're always less per our graph. But then you notice that company A starts to be more expensive once you hit that even point where they're equal. So beyond that, it's cheaper. So beyond 200 miles, it's cheaper to use company B. Okay, so that's kind of where you might use that in real life if you're comparing enterprise and budget car rentals. Okay. So example 15 is similar, so I'm going to leave that to you all. Okay. And we'll look at us in example 16. At a museum, adult tickets cost $30 and children cost $15. On Saturday, there were 13 more children tickets sold than adult tickets sold. The total amount paid for adult tickets is $11.40. how many adult tickets and how many children's tickets were sold. So this we're going to kind of look at as a system of functions. So I'm going to let X denote adult tickets. I'm going to let Y denote children tickets. And tickets themselves, we know that there's 13 more children tickets sold than adult tickets. Okay, and then I can do the amount paid. We know that it's $30 per adult ticket, $15 per children's ticket, and in total $1,140 was taken. So I can really do this with just these two equations. So this would be kind of step 1, step 2, step 3, and then we'll go over and do a step 4. I want to solve this for y because I want it in y equals mx plus b format for simplicity. So I'm going to subtract the 30. So I'm going to have 15y is equal to negative 30x plus 1140. We're going to divide by 15 on both sides of my equation. Y is equal to negative 2x, and that's 76. And y'all will have to take my word for it. So step 4, I'm going to rewrite both of my equations. Okay. So we know y is the children's tickets. And we'll probably find that last because both of these equal y. So since they equal the same thing, I can claim down here that they're equal. And just solve for x adults tickets. And figure out how many adults tickets we sold. So I'm going to add my 2x. So that's 3x plus 13 is equal to 76. I'm going to subtract my 13 on my 3x is equal to 63. We're going to divide by 3. We're going to say x is 21. So 21 adult tickets. So then I need to go back. I need to go back. Excuse me, I'm so sorry. I need to go back to figure out how many children's tickets was sold. Well, I know that x is 21 in this first equation. This one's simpler because I don't have to multiply the x by anything. Plus the 13 tickets. So y is equal to 34 children's tickets. Okay. And I think I've already kept you all on for an hour. The others work the same way. Okay, and I may submit a supplemental video later on in the week where I work those, but it won't count toward the grade this week for the Edpuzzle grade. Alright, so I thank you all for taking the time to join me, and I'm sorry for all the coughing along the way. It seems like the pollen or something is trying to take a hold of me. Well, I thank you all for joining me, and as always, reach out if you want some more help with those word problems. We can always set up a Teams meeting for some office hours.